Hi everyone, I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Ministry of Aeronautical Engineering, Dundigal, Hyderabad. In this video, I would like to present the differential equation solution methods in first order and first degree differential equations. So, how to solve the problems in variable separable. Variable separable method, already in the previous session we have done how to proceed through variable separable method. In this video, we will do some problems on variable separable method. Then suppose if the given equation is not in the variable separable form, how to reduce into variable separable form by taking substitution. We will do some problems on that also. And then we go to the homogeneous differential equations. Now, we will solve some problems on variable separable method. Solve the differential equation 3e power x tan y dx plus 1 minus e power x secant square y dy is equal to 0. So clearly it is the first order and first degree differential equation. I can solve this differential equation by separating the variables. That means x variables on dx side and y variables on dy side, and then integrating we will get the required solution. So here the given equation is 3e power x tan y dx plus 1 minus e power x secant square y dy is equal to 0. Now I write the x terms on dx side, that is 3e power x by 1 minus e power x of dx. Here 1 minus e power x there. So I can write in the denominator, and tan y can be written in the second term, that is secant square y by tan y dy is equal to 0. Just I am making here the variables of x on dx side and y variables in the second term. In the second term we have secant square y, and in the first term we have tan y. So on writing in the denominator you get secant square y by tan y dy is equal to 0. Now on integrating both sides, integral 3 into e power x by 1 minus e power x dx plus secant square y by tan y dy is equal to, we'll get some constant, let it be c. So we know that the formula integral f dash x by f of x dx. What is the formula? Log modulus f of x plus c. So here 1 minus e power x, 3 constant, I can write outside. It is integral 1 e power x by 1 minus e power x dx. So on differentiating the denominator, here f of x is 1 minus e power x. On differentiating you will get 1 constant 0, you will get minus e power x. So that will appearing in the numerator except minus sign. So I can write minus 3 into log of the f of x is 1 minus e power x. That is the integration of the first term. Plus second term, integral secant square y by tan y dy. So tan y derivative is secant square y dy. So I can write the second term also by using the same formula, integral f dash y by f of y dy. So it is log tan y, and I can write it is log c on the right hand side. Or I can write this as log 1 minus e power x whole power minus 3 plus log tan y is equal to log c. Or I can write, so this is log m plus log n notation. So I can write this as log m plus log n means log mn. So I can write it as log 1 minus e power x whole power minus 3 into tan y is equal to log c. Or on eliminating both sides log, then you'll get tan y by 1 minus e power x whole power 3 is equal to c. So this is the required solution of the given differential equation. Already answer is given, tan y by 1 minus e power x whole cube is equal to c. So here just we separate the variables and we do integration and we get the required solution. So now we see another problem under the same model, that is variable separable form. So here also the problem is first order and first degree derivative dy by dx differential equation is equal to e power x minus y in the power plus x square into e power minus y. So I can rewrite. First what I have to do is I have to separate the variables. So dy by dx can be written as e power x by e power y plus x square by e power y. So just this is, so what we will get in the numerator, e power x by e power x plus x square. In the denominator we will have e power y. This is dy by dx. So now on separating the variables, that means what? Y variables on dy side and x variables on dx side, we'll get e power y dy is equal to e power y dy is equal to, here on the right hand side, e power x plus x square of dx. So now the variables, x variables on dx side and y variables on dy side. So on taking integration both sides, you'll get the integrating constant also, and integral e power y. What integral e power y? That is e power y only is equal to, the right side, it is e power x integration, e power x plus x square dx. The integration is x cube by 3 plus the integrating constant c. So clearly this is the solution of the given differential equation. And we do another problem based on the variable separable form. So here also we can separate the variables. How I can do this? E power y. First write the given equation, dy by dx is equal to e power y sin x dx plus 2 sin x dx minus e power y cos x dy. So the problem may be there is no dy by dx, I think. So the problem is like this, e power y plus 2 of sin x dx minus e power y cos x dy is equal to 0. The problem is like this only. There is no 2 times already appeared, already dy by dx is there. So it is again dy by dx, so please cancel out. Then what will be here on separating the variables? How I can separate? How I can separate the variables? E power y I can take outside. E power y, this is 2 sin x dx. So sin x on taking outside, sin x. So what is this? E power y. So I'll write it is, there is a small wrong in the problem. I'll do this. E power y plus 2 of sin x dx is equal to e power y cos x into dy. So now on writing d power sin x by cos x dx. Just I am writing cos x in the denominator on the right left hand side, and write e power y by e power y plus 2 dy on the right hand side. Just I separated the variables, x variables on dx side and y variables on dy side. The problem is here there is no dy by dx. Please note it that point. So what is integral? This is tan x dx On the left hand side it is tan x dx, and it is e power y by e power y plus 2 of dy. Now on taking integration both sides, integral tan x dx is equal to integral e power y by e power y plus 2 of dy. Then what it is? Integral tan x means, we know that the integration of integral tan x is log secant x. Integral tan x means integral sin x by cos x. Am I right or not? So sin x by cos x. This is, if you assume cos x is f of x, then minus sin x is derivative. Then it is looks like minus f dash x by f of x dx. That means it is minus log cos x. Or I can write it as log secant x. The formula is log secant x, and it is looking like the right hand side e power y by e power y plus 2. So e power y plus 2, if you take as f of y, then the derivative of e power y plus 2 is e power y plus 0. That means e power y only. So it is also looking like f dash of y by f of y dy. So this can be written as log of e power y plus 2 plus log c. That is the integrating constant. So on eliminating log, or I can write this is log m plus log n notation on the right hand side. So what I can write here, log secant x is equal to, so what is on the right hand side? Log of c into e power y plus 2. So that is equal to secant x, that implies secant x is equal to c into e power y plus 2, which is the required solution of the given differential equation. So these are all the problems which are possible to separate the variables and then integrating easily. In some problems, it is not possible to separate the variables. In that case, we take substitution, some suitable substitution, and we convert the problem into variable separable form. So how this I can explain with the method. Suppose if the given differential equation is of the form dy by dx is equal to f of x plus y. If the right hand side is a function of x plus y, then it is not possible to separate the variables. Then what to do? Then how to reduce this into variable separable form? So this can be done by taking the substitution x plus y is equal to t, so that the differential equation 1 will get in the new variables x and t. And it can be separate the variables by using variable separable method, and on integrating we'll get the solution, and finally we replace t by x plus y. So this is also very simple method, and how it will be I will explain in the next slide. So see this. Suppose given differential equation is dy by dx is equal to f of x plus y. Then put x plus y is equal to t. Then on differentiating equation 2 with respect to x on both sides, we'll get x derivative 1 and y derivative dy by dx. So that the left hand side will get 1 plus dy by dx is equal to right hand side dt by dx. Or dy by dx can be written as dt by dx minus 1. So on substituting the equation 4 in equation 1, we get dy by dx. This is dy by dx. So this is also dy by dx in the terms of dt by dx minus 1. So on substituting, we will get dt by dx minus 1 is equal to function of t. The equation 1 becomes dt by dx is equal to dt by dx minus 1 is equal to f of t. Or what I can write it is dt by dx is equal to 1 plus function of t. That means the right hand side is full of a function of t variable term only. Now I can separate the variables. On writing t term on dt side, you will get dt by 1 plus f of t, and on writing x term on the right hand side that it is dx, and on integrating both sides you will get the required solution. So just we take whatever may be the function of some of the terms, that will be treated as another variable t, and the whole function will get into the form of t and x terms. Instead of y and x terms, the new variables t and x, and on integrating we will get the required solution by using variable separable form. This is another small substitution method, and here we will see. So this is dt by dx minus 1 is equal to f of t, or dt by dx is equal to 1 plus f of t, or dt is equal to f of t plus 1 of dx. So on separation of variables, dt by f of t plus 1 is equal to dx. So on taking integration both sides, the left hand side which is function of t purely, and the right hand side integral dx plus c, where c is the integrating constant. So whenever you observe this is a function of x plus y, it is not possible to reduce the given equation to variable separable form. We use a suitable substitution for x plus y or x plus y plus 1 as another variable t, and so that all the equation will change into the new variables. Now we see some problems on this substitution method. So how to solve? Dy by dx is equal to x plus y whole square. So clearly here the problem is not considering in the form of variable separable form, because x plus y term is there. It is not possible to separate the variables. In this case, we take the substitution. What is the given problem? Dy by dx is equal to x plus y whole square. So how to solve this? Put x plus y is equal to t. Put x plus y as another variable t, as said in the previous procedure. On differentiating with respect to x derivative 1 and y derivative, dy by dx is equal to the right hand side term dt by dx. Or what is dy by dx? Dy by dx is dt by dx minus 1. So on substituting this in the equation 1, so what can be replaced? Dy by dx can be replaced by dt by dx minus 1 is equal to t square. Or what I can write? dt by dx is equal to t square plus 1. So minus 1 on writing on the right hand side, it will give plus 1, and dt by dx is equal to t square plus 1, and the right hand side term is a complete function of t. Now on separating the variables, dt by t square plus 1 is equal to dx. So now on taking integration both sides, we'll get the integrating constant also. Integral 1 by 1 plus t square dt. So what is the derivative integration? Tan inverse t is equal to integral dx, x plus c. But what is the final value? So you have to replace t by our substitution x plus y. So the required solution is tan inverse of x plus y is equal to x plus c. Our original problem is in terms of x and y, and the final solution also in the terms of x and y only. So t is replaced by x plus y, so that the final solution is tan inverse of x plus y is equal to x plus c. So here the method, just we convert this method into variable separable form by using the substitution x plus y is equal to t. This is very simple method. So similarly, we'll go another problem, same substitution method. So here what is there? Dy by dx is equal to 1 plus tan y minus x. So just you replace 1 plus tan, you write like that, then you can reduce easily. Just I will show how to separate, then you do at your own. So here the problem is dy by dx is equal to 1 plus tan y minus x. So then what is the method to be applied. To apply variable separable form, it is not possible because the terms are not possible to separate the variables. So what to do? We have to take some substitution. So what substitution you have to take? Put y minus x is equal to some other variable t. Then on differentiating with respect to x, dy by dx minus 1 is equal to dt by dx. Or what is a dy by dx? It is dt by dx plus 1. Now on substituting in equation 1, we'll get 1 plus dt by dx is equal to 1 plus tan u. So 1 will gets cancelled. Dy by dx is dt by dx plus 1. So 1 gets cancelled and tan u, not tan u, it is tan t, because it is tan y minus x, it is tan t. Then dt by tan t is equal to dx. So this is the model of separation of variables. Already separation of variables has been done, and on integrating both sides, we'll get integral. What is integral? Integral tan t, that is cot t dt, is equal to integral dx plus c. So what is integral cot t formula? Integral cot t dt. So integral cot t means cos t by sin t dt. So if you treat this as f dash t by f of t, if sin t, f of t, if you treat, then what is f dash of t? Cos t. So integral f dash of t by f of t, what you will get? The value is log of sin t. Am I right or not? This is f dash of t by f of t form, and this is log sin t. So the integration is log of sin t. On the right hand side, what is integral dx is x plus c. But what is sin t? What is t? Y minus x. So finally, we have to replace t for the final solution is, what is the solution? Log of sin t means y minus x is equal to x plus c. This is the required solution of the given problem. Just replace t for y minus x, that is the required solution in the terms of x and y. So in this way, we can solve the problems which are not in variable separable form, and just on substituting some variable, term by another variable, if it is reduced to variable separable form, then we can apply variable separable form. That is separating of variables and then integrating, we will get the required solution. So this is also similar method. Dy by dx is equal to 4x plus y plus 1 whole square. Here also it is not possible to separate the variables. X variables dx side and y variables dy side. It is not possible. So in this case also, what we have to do is, we have to substitute for 4x plus y plus 1 by another variable. So the similar problem, this is also dy by dx is equal to 4x plus y plus 1 whole square. So what is the substitution we have to take here? Put 4x plus y plus 1 is equal to some variable t. So then what is the value? And differentiating 4, x derivative 1. What is y derivative? Dy by dx. 1 derivative 0, t derivative dt by dx. And what is dy by dx? dt by dx minus 4. So this is equation 1, let this is, and this is equation number 2. Now substitute 2 in 1. So what you can replace in one first equation, then 1 implies. So dy by dx is replaced by dt by dx minus 4 is equal to, the right side 4x plus y plus 1 can be replaced by t. So that is equal to right side term t square. or I can write dt by dx is equal to t square plus 4. So now the right side term is fully function of t, and I can separate the variables dt variable, t variables on dt side and x variables on dx. There is no x variable, this constant, and we write it is dt by t square plus 4 is equal to dx. So on taking integration both sides, we'll get the integrating constant also. Integral a square plus x square dx. What is the formula? Integral x square plus a square dx. So this is 1 by a into tan inverse x by a plus c. This is the formula. So here also 1 by 2 into tan inverse t by 2. It is also looking like 1 by x square plus a square into dy. So the right side integral dx, that is x plus c. But finally what we have to substitute? For t, we have to substitute 4x plus y plus 1. Then tan inverse 4x plus y plus 1 by 2 is equal to x plus c, which is the required solution of the given differential equation. So the last three problems are converted into a variable separable form by using a simple substitution, and it can be solved by using very easily. So this is the model 1 of the solution of the differential equations of first order and first degree, variable separable form. In the next model, we are going to see the homogeneous equations. Homogeneous differential equation, that is method 2. So if you consider the two forms as one model, it is method 2, homogeneous differential equation. So when we say that a differential equation is a homogeneous differential equation, what is a homogeneous function? A function f of x comma y is said to be a homogeneous function if it is having the same degree in all its terms. Suppose if we take f of xy is x square plus y square plus 2xy. It is a homogeneous function of degree 2. Am I right or not? In the first term, the degree is 2. In the second term, the degree is 2. In the third term, x power 1, y power n, the degree is also 2. So we call it as a homogeneous function of degree 2. So homogeneous function of degree 2. Suppose if I take another example, f of x comma y is equal to x square plus y square by 2xy. So what is the degree of the homogeneous function here? So in the numerator it is 2 degree, in the denominator it is 1 degree, and we say that it is a homogeneous function of degree 0. So how we can say that it is a homogeneous function of degree 0? I'll give a small example. And suppose if the given function f of x comma y is x square plus y square is a homogeneous function of degree 2, you can observe in each term there is a degree 2 or not. Or you can see that suppose if we replace x by kx and y by ky, and if it is in the form k power n into f of xy, then I say that it is a homogeneous function of degree 2. So for this f of xy, I am writing x for kx and y for ky. Then what we will get in the right side? It is k square x square plus k square y square. So what is the common term? K square is common term. It is x square plus y square. So this is in the form k power n into f of x comma y. That means what? It is a homogeneous function of degree n. N means here it is a 2. So suppose if you want to find the degree of this function, we write f of kx comma ky. In place of x we write kx. In place of y we write ky. Then what we will get? K square x square plus k square y square by 2 into x means kx and y means ky. So numerator k square common term, x square plus y square by 2 into k square into xy. So k power 2 gets cancelled. It is k power 0 into f of xy. Isn't it? X square by plus y square by 2xy. It is a function of xy. So it is k power 0 into f of xy. And I say that it is a homogeneous function of degree 0. So simply I can say that. So in the numerator it is degree 2. In the denominator it is degree 2. So on cancelling out degree, you'll get the function of degree 0. So when we say that it is a only homogeneous function, not homogeneous differential equation. So when we say that a differential equation is a homogeneous differential equation. So in each term of the given differential equation having same degree, then it is a homogeneous differential equation. Or I can say that if dy by dx is equal to f of xy by phi of x comma y, if it is a homogeneous function of degree 0, if it is a homogeneous function of degree 0, then dy by dx is equal to f of xy by phi of xy is a homogeneous differential equation. So you can say that in two ways. If the given function is a homogeneous function of degree 0, then dy by dx is equal to f of xy is a homogeneous differential equation. Or in all the terms of the given differential equation are same degree, then also we say that it is a homogeneous differential equation. So here you can see the examples. Dy by dx is equal to 3xy plus y square by 3x square plus xy. It is 3x square plus x plus y. So this is x square. So what is the degree? In the numerator is 2 degree. This is x power 1, y power 1, 2 degree plus y square second degree term. In the denominator also it is second degree term. It is also second degree. So numerator also second degree and denominator also second degree. So dy by dx is equal to a homogeneous function of degree 0. So what we call it is a homogeneous differential equation. Am I right or not? Here also it is a homogeneous differential equation. You can observe easily. If dy by dx is equal to homogeneous function of degree 0, then it is a homogeneous differential equation. Right. So when the given differential equation is a homogeneous differential equation, so what procedure we have to follow to get the solution? So this also we can convert into a variable separable form by using the substitutions y is equal to vx or x is equal to vy based on the given equation. We can reduce the given differential equation y is equal to the dy by dx is equal to f of xy by phi of xy can be reduced to variable separable form by taking the substitutions y is equal to vx or x is equal to vy. So this I will explain in the next slide. So see this slide. How to proceed to solve the differential equation. If the given equation is in the form dy by dx is equal to f of xy by phi of xy and it is a homogeneous differential equation, then we take either the substitution y is equal to vx or x is equal to vy, any one according to the given differential equation. So you can take any one of them, y is equal to vx or x is equal to vy. Suppose if you take y is equal to vx, then what will be dy by dx? Suppose if I take dy by dx, what will be dy by dx? So v into x differentiate is the 1. v into x derivative 1 plus x into dv by dx. So you have to replace dy by dx by v plus x into dv by dx. Suppose if you take x is equal to vy, then the dx by dy will get dx by dy. What will be dx by dy? V plus y into dv by dy. So we can use based on the given problem either this substitution or x is equal to vy substitution. If y is equal to vx, then the derivative dy by dx will be v plus x into dv by dx. If you take x is equal to vy, then the substitution will be dx by dy is equal to v plus y into dv by dy. Now substitute these value in the given equation 1, and then on substituting this in the equation 1, what we will get? V plus x into dv by dx is equal to, in the numerator, function of x comma y place of vx will get, in the denominator, phi of x comma y place of we get v into x, implies v plus x dv by dx is a complete function of v only, because it is x square term here, it is x square term, this will get cancelled and we'll get the right side pure function of v. Now take v on the right hand side, then x into dv by dx is equal to function of v minus v. So now it is in the variable separable form. The right hand side is a pure function of v and left hand side x into dv by dx. Now on separating the variables, dv by f of v minus v is equal to dx by x. Just to separate v variables on dv side and x variables on dx side. Now on integrating, you'll get the required solution, and plus c is the integrating constant. This is also like substitution method. So before use the substitution method, we have to identify whether the given equation is a homogeneous differential equation or not. So that can be done by, already I told you that, so how to see whether the given equation is a homogeneous differential equation or not. So this, the next slide, this is an example how to solve the homogeneous differential equation. So the given equation, you can observe that x square dy plus y into x plus y of dx is equal to 0. So it is the homogeneous differential equation because the degree, you can observe it is x square 2 degree. So here it is y into x 2 degree, y into y 2 degree. All the terms in the given differential equation are same. So I can say that it is a homogeneous differential equation. So I can write this equation as dy by dx is equal to minus of y into x plus y by x square. Now to solve this equation, we take the substitution y is equal to vx. So on taking y is equal to vx, what will be dy by dx? 1 plus v plus x into dv by dx. So the equation 2 will get in the form. So 2 implies. So how the equation 2 will change, just observe. Instead of dy by dx, I can write v plus x into dv by dx is equal to right side minus y means vx, x plus y is replaced by vx, and the denominator x square is as it is, just copy down. So or I can write it as, on taking out x I can take outside, minus v x square 1 plus v by x square. On the left hand side, v plus x into dv by dx. So here x square will get cancelled. It is minus v square. So on the left hand side, it is v plus x into dv by dx is equal to minus v into v square. Just add it out, v square. Am I right? Minus v into 1, minus v into v square. So now I can write on the right hand side, v on writing this side, you'll get what you will get? dv x dv by dx is equal to minus 2v. On writing plus v right side, you get minus v, and minus v already is there, minus 2v minus v square. So now the right hand side is a pure function of v only, and it is x dv by dx is equal to pure function of v. So we'll go to the next slide. The solution may be here, I think. So dv by 2v plus v square, just, so already in the previous slide already we have seen, minus on taking outside 2v plus v square will get. So dv by 2v plus v square, am I right? dv by 2v plus v square is equal to minus, I have written on the right side. So you know the methods of integration, how to solve it. Integral dv by, what I can take outside? and taking outside v, you get v2 plus v. On the right side, it is minus log x plus, you can take log x or log c. So now, how to integrate this? You can go for partial fraction method. So 1 by v into 2 plus v. How you can write it is a by v plus b by 2 plus v. Just I am explaining, or without doing partial derivative also you can write straight away. But we go as per the procedure. 1 is equal to a into 2 plus v plus b into v. Just LCM v into 2 plus v. So suppose if I put v is equal to minus 2, what you will get? 1 is equal to this entire term 0 minus 2 into b, or b is equal to minus 1 by 2. This is one constant obtained. Similarly, you find a value also. So how will get a? On putting v0, in the equation. So put v is equal to minus 2 here. So what you will get here? Put v is equal to, I will show it. V is equal to 0. Just how to proceed using partial fractions. So on putting v0 in this equation, what you will get? v0, left side 1 and a into 2 plus 0 plus b into 0. So entire term 0, or a is equal to, you will get 1 by 2. So you get a 1 by 2 and b is equal to minus 1 by 2. So on replacing, this is 1 by 2v. So how I can write it is 1 by 2v dv. First term, there is no minus here, it is integral 1 by 2v dv. The second term, so b will obtain minus 1 by 2. B will get minus 1 by 2. So minus integral 1 by 2 into what you will get? 2 plus v dv is equal to minus log x plus log c. I hope all are getting understand. So this is 1 by 2 into v dv. That means what? 1 by 2 log v. Am I right? So 1 by 2. 1 by 2 plus v integration. So this is also log 2 plus v is equal to minus log x plus log c. So this is the required solution. Now we can eliminate the logarithm both sides, and we can replace finally v for what is our substitution? V is equal to what we have taken, y is equal to vx. So finally what we have to substitute? V is equal to y by x. This is the suitable substitution for the given problem. And finally on substituting v is equal to y by x, the entire solution will get in the form of x and y terms and the integrating constant. This is the required solution, and this is the method of finding the solution by using the homogeneous differential equation. If it is in homogeneous form, we put y is equal to vx, so that dy by dx will get v plus x into dv by dx, and the whole problem will convert it into a variable separable form, and it can be solved by easily by using previous separation of variables method. So this is the procedure how we are going through a v plus x dv by dx. So what I have written in the raised 2v plus v square, that he has written here. So similarly we can solve this equation also. This is also homogeneous differential equation. Y square minus xy, second degree term, dx plus x square dy. So this is also a homogeneous differential equation. What is the given equation? Dy by dx is equal to y square minus under xy minus y square by x square. Am I right? So I'm writing dy by this term, dx by x square, or dy by dx is equal to this by this. I'm writing left hand side or right hand side. So minus will get, on multiplying minus sign, you get xy minus y square by x square. So clearly it is a homogeneous function of degree 2 in the numerator. It is a homogeneous function of degree 2. So clearly it is a homogeneous function of degree 0. So all in all, it is a homogeneous differential equation. So to solve this equation, what method we are going through? We take the substitution y is equal to vx. So that what is dy by dx will get v plus x into dv by dx. So the entire equation, what will get v plus x into dv by dx is equal to, so tell me the equation x into, what is y? We can replace y plus the vx minus, instead of y I can write vx, that means here you will get v square x square by what you will get in the denominator, x square is same as x square. So in the numerator you can take out x outside. This is v square x square, this is vx square, this is vx square only, this is the term x into vx minus vx whole square. So what is the common? X square on taking outside, we will get v minus, in the second term we will get v square by x square remains same. So this x square and this x square will get cancelled. Left side v plus x dv by dx, and this v and this v also gets cancelled. So what we will get? X dv by dx is equal to the value minus v square only. Am I right or not? Minus v square. Now it is possible to separate the variables. I can write dv by v square is equal to minus dx by x. So on integrating both sides, what is on integrating? Integral dv by v square. Integral dv by v square is equal to minus integral dx by x plus c. So what is integral dv by v square? 1 by x square it is looking, and it is nothing but v power minus 2 dv. So integration v power minus 2 plus 1 by minus 2 plus 1. You know that integral x power n dx, x power n plus 1 by n plus 1. So the value is v power minus 1 by minus 1. So this is minus 1 by v integration. Am I right or not? So on the right hand side it is minus log x plus c. So finally what you have to replace? V for v is our substitution. What is v? Y is equal to vx, or v is equal to y by x. So this is minus x by y is equal to minus log x plus c is the. So this is the method which is described when the given equation is an homogeneous differential equation. Just we convert this also into variable separable form, and we will transform this into variable separable form, and by using separation of variables we can find the solution of the given differential equation. So in the next class I will see some problems on non-homogeneous equation, how to solve the non-homogeneous equation, and what are the methods to find how to find. So thank you for listening.
Like, share and subscribe. Hit the bell icon for more updates.